Welcome back to the Python Fundamentals series. Today we'll be talking about object-oriented programming. Object-oriented programming is a programming paradigm that organizes code into objects, which are instances of a class. Essentially, this paradigm emphasizes encapsulation, inheritance, polymorphism, and abstraction. I'll be going through each concept in detail to give you a good understanding of object-oriented programming. So what is object-oriented programming? Basically, object-oriented programming is a way of structuring programs by bundling related properties and behaviors into individual objects. And these are often called classes, which essentially acts as a blueprint for each object. So there are four key concepts when creating an object. First, we have the class, which is essentially the blueprint of the object itself. The object, which is an instance of the class. Attributes, which are variables that belong to an object or class. And methods, which are functions that belong to an object or the class. So let's define a class. A class is defined by using the class keyword in Python. It can have attributes and methods. So here's an example of a class. We have a class dog, and we have a class attribute of species, and this species attribute will be shared among all dog classes. And we have the constructor method, which essentially initializes the object attributes. So here we have the name and age for the dog class, and we have to use self to reference the class itself. And finally, within the dog class, we have a instance method, bark, which is essentially a function for the class. So let's have a look at the dog class that we just created. After we made a class dog, we want to initialize two dog objects, one for dog 1 and one for dog 2. And for the first dog object, we'll pass in buddy and 3. Buddy is the name and 3 is the age. For the second dog class, we'll pass in max and 5. Once we've initialized the objects, we can interact with the objects. And here we have 3 print statements. The first one will be trying to print out the name of dog 1, and we'll be expecting to get buddy. The second print statement will be printing out the age of dog 2, which is expected to be 5. And finally, we'll be using the dog instance method bark. As you can see, the program has printed out the expected output. Let's talk about encapsulation. Encapsulation is essentially the bundling of data and methods that operate on the data into a single class. This helps restrict direct access to some components of the object by using access modifiers. So in Python, we have 3 access modifiers: public, private, and protected. For public modifiers, we can access it from anywhere. If it's private, we can only access it within the class. And if it's protected, it can only be accessed within the class and its subclasses. So let's have a look at an example of encapsulation. Here we've declared a class bank account, and within the class we have attributes such as the owner and the balance. And the owner attribute is public, which means we can access it anywhere, whereas the balance attribute is private, which means we can only access it within the class. Within the class, we have 3 methods. The first one is deposit. Essentially, it's a method to deposit money. The second one is withdraw, a method to withdraw money. And the third one is getBalance. And this method is used to check the balance of our class. We have this method because our balance attribute is private and we can only access it within the class. So once we have the bank account class created, we can create an object of bank account with Alice and a starting balance of 1,000. To showcase accessing the public methods, we're going to print out the public method deposit and withdraw. So here you see we have successfully used the class methods. So here we have a print statement that tries to access the balance attribute. But remember, since the balance attribute is a private attribute, when we try to access a private attribute, we will be getting an attribute error. As you can see, we hit the error. So in order to access a private attribute, we have to use an access method, which is the function getBalance. So here we're using the getBalance public method, and when we run it, we successfully got the balance of the account. Moving on to inheritance. So inheritance allows a class to inherit attributes and methods from another class. We usually call it a child class and a parent class. And essentially this promotes code reuse and a good hierarchical classification. Here in this diagram, we can see we have a parent class of animal, which contains name and a function speak. And we have two other child classes, dog and cat, and they have their own respective speak function or method. As you can see, we have three classes. We have the parent class animal. As mentioned in the diagram, we have a attribute name, and also it has a method speak. And then we have two other classes, a dog class and a cat class, and they each have a speak function. We can see in the parameter of both the dog class and the cat class is passing through animal. This is how Python shows that both the dog class and the cat class is a child class of the animal parent class. So here we're going to try and retrieve the names of the dog and cat to showcase that even though we've actually created the object dog and cat where a name attribute doesn't exist, since it's inheriting from the parent animal class, we can actually still retrieve a name attribute. So here we have dog.name and cat.name, and we'd expect it to print out the respective names of the animals. And here we're going to try to use both methods of the cat and dog classes. You can see that the parent class also has a speak method, but Python always prioritizes the child's methods over the parent's methods. So here you can see the outcome of the different class methods for dogs and cats. Next we have polymorphism. So polymorphism allows objects of different classes to be treated as an object of a common superclass or parent class. It essentially enables methods to behave differently based on the objects that cause them. Here we see an example of polymorphism. We've created a function animalSound which calls the animal's respective methods, in this case speak, and we've created two objects, dog and cat, and when we try to call the function animalSound, it would take each class's respective methods. So essentially one function can have different outputs. Here you see we call the same function, but it has different outputs. Finally, we have method overriding. We've seen that in action already, where the child class's method actually overwrote the parent's class method. Just to give you a clear example of method overriding, here we have an animal class with a method speak, which returns animalSound. And then we have a dog class, which is the child of the animal parent class that has a method speak, which returns wolf. And when we initialize the objects and call the dog method, we'll expect the program to use the child's method. Thank you for continuing watching the Python Fundamental series. This was a video on object-oriented programming. Please like and subscribe if you appreciate these videos. I hope you learned something, and please stay tuned for the next videos in the series.